Example 1, how are the diagonals of a kite related? So first off, a kite is, as far as I know, a quadrilateral. This book may be invented, I don't know. When I was in high school, kite was not one of the quadrilateral types, but it does have some properties associated with it, so it's useful, I guess. In their estimation, a kite, if they use the word kite, they're describing a quadrilateral with consecutive sides congruent. So this side's the same as that, this side's the same as that. These are not necessarily the same as each other. All right, that's what a kite is. It's somewhat like a rectangle, but rectangle opposite sides are congruent, or parallelogram opposite sides are parallel and congruent. So this is what a kite looks like, and they want to know how the diagonals of a kite are related. And once again, here's another word that you may or may not know, the word diagonal. Anytime you're talking about the diagonal of a polygon, you go from any vertex through the polygon to an opposing vertex. That's called a diagonal. All right, so BD is a diagonal, AC is a diagonal, and those are all the diagonals. I can't go, if I'm at D, if I go to A or C, I've got sides, not diagonals. So they have to go through the figure to be called a diagonal. So, with the properties given, and I'm trying to figure out what's true about these two diagonals, first thing I'm going to do is I'm going to look at this as far as triangle pieces. So, we've done a lot of stuff with triangles this year. So, imagine we look at triangle ABD. Versus triangle BCD. Okay, given, since it's a kite, this side is the same as this side, and this side is the same as this side. By the reflexive property, BD is congruent to itself. Can we see that these two triangles are congruent to one another? Yeah. So just based on that alone, if these two triangles are congruent, that means all the corresponding parts of those triangles are congruent. These sides are congruent to each other, so we go across. This angle is congruent to this angle. These sides are congruent to each other. If we go across, this angle is congruent to this angle. And with nothing else to figure out at this point, just based on that information, both these angles got cut in half, which makes BD an angle bisector of B and D, right? So I can put that down as one of the properties. So BD is an angle bisector of angle ADC and angle ABC. That's one property. That's not all the properties, but that's something that's true just based on that much. And based on that much, I can go ahead and keep those equal angles marked in there. So this is true always. These two angles are congruent, those two angles are congruent. So now I'm going to pretend I didn't draw these triangles on top of all this stuff here. And now let's look at another thing that we can say. If I look at triangle AXB, which is right here, and we look at triangle BXC, which is right here. Once again, we already know this side is congruent to this side. We just figured out these two angles are congruent to one another. XB is congruent to itself by the reflexive property. So now these two triangles have to be congruent via the side angle side theorem, which means that this angle right here is congruent to that angle right there. If they're congruent and they make a straight line, how big are they? 90. They have to be 90 and 90 to make 180, right? So I know for a fact that this is perpendicular because there's right angles. If there's right angles there, this is also a straight line. There's also right angles here. So all four of those angles in the middle are right angles. In addition, these two triangles are congruent, which means their corresponding pieces are congruent. I know that AX, which is this piece here, is congruent to CX, which is this piece here, because they're both opposite equal angles in congruent triangles, corresponding parts. So BD not only is perpendicular to AC, but it also cuts AC in half, which makes it a perpendicular bisector. So the other fact I know is that BD is the perpendicular bisector of AC. Notice that AC is not the perpendicular bisector of BD. BD is not getting cut in half. This piece does not equal that piece. So if the kite, wherever the equal sides are here, the diagonal slicing through the equal sides basically is the one that bisects both the angles and the other diagonal perpendicularly. All right? So in general, when we see a kite, that's our takeaway. When they say the words, something is a kite, you immediately know all these facts are true, which leads us to specifically these set of angles congruent, this set of angles congruent, this set of angles are all 90, and these two sides are congruent. As soon as they say kite, you immediately know that if all that stuff's drawn in there. Right? And again, as with most things in geometry, a property leads us to find a missing piece, right? So the property is going to allow us to write equations to find missing things.